Picture this, a machine the size of a building. No flames, no fuel tanks, no exhaust pipes. Just a hollow metal donut filled with gas heated to 100 million degrees Celsius. That's 7 times hotter than the core of the sun. And on January 20th, 2025, that machine, buried in a research facility in Hefei, China, did something that scientists have been trying to do for 80 years. It held that superheated star-like plasma completely stable for 1,066 seconds, 17 minutes, more than double any record ever set by anyone anywhere on Earth. China's artificial sun is the most ambitious energy machine ever built. And on January 20th, 2025, it did something that changed the rules of the game forever. And it just shattered the world record for nuclear fusion. And 6 months later, Beijing launched the biggest fusion energy company on the planet, backed by $2.1 billion in state capital. Now here's the question nobody in Washington seems to want to answer. While China is building the energy source of the future, what is America building? In this video, we're going to break down exactly how this technology works. No PhD required. We're going to explain why this record matters more than people realize. And we're going to show you what it means for the global balance of power over the next 25 years. Stay with us, because this one is important.
To understand why this matters, you need to understand the energy problem that nobody wants to talk about honestly. The world runs on fossil fuels. About 80% of global energy still comes from oil, coal, and natural gas. And for all the investment in solar and wind, those sources have a problem. They're intermittent. The sun doesn't always shine. The wind doesn't always blow. Nuclear fission, the kind we already use in power plants, is clean and reliable. But it creates radioactive waste that lasts for thousands of years, and nobody wants a reactor in their backyard. So for 8 decades, scientists have been chasing the real nuclear prize, fusion. Here's the key difference. Fission splits a heavy atom apart that releases energy, but also radioactive waste. Fusion does the opposite. It takes 2 light atoms and smashes them together. That releases even more energy and produces almost no long-lived radioactive waste. The fuel? Hydrogen. Specifically 2 forms of hydrogen called deuterium and tritium. And here's the kicker. Deuterium is extracted from seawater. The ocean contains enough deuterium to power human civilization for millions of years. If fusion works, it isn't just a new energy source. It's the last energy source humanity will ever need. So why don't we have it already? The joke in physics circles has always been, fusion is 30 years away, and always will be.
Because the challenge is almost incomprehensible. To fuse hydrogen atoms, you need to recreate the conditions inside a star. Temperatures of 100 million degrees or more. And then, you need to hold that fireball in place long enough to extract energy from it. You can't use a metal container at those temperatures. The plasma would vaporize it instantly. So scientists use powerful magnetic fields to create an invisible cage, a magnetic bottle that holds the plasma away from any physical surface. The machine that does this is called a tokamak. And the key challenge has always been, how long can you hold the plasma stable? In 2017, China's East reactor held plasma for 100 seconds, a breakthrough at the time. In 2023, they pushed it to 403 seconds. And then, on January 20th, 2025, 1,066 seconds. More than 17 minutes of continuous, stable, star-hot plasma. But here's the geopolitical question underneath all of this. The United States has been the dominant power in science and technology for a century. The Manhattan Project, the moon landing, the internet, Silicon Valley. And now, in the race for the most important energy technology in human history, China is leading.
China is spending an estimated $1.5 billion per year on fusion research. That's nearly twice the entire US federal fusion budget. They have at least 5 major fusion facilities either operating or under construction. The United States has 0 fusion demonstration reactors planned. How did this happen? And what comes next?
Okay, let's break this down simply, because the technology behind this is genuinely mind-blowing, but it's actually not that hard to understand. Think of it this way. You know how the sun works? The sun is basically a giant ball of hydrogen gas, so massive that its own gravity crushes the hydrogen atoms together until they fuse. That fusion releases enormous amounts of energy as heat and light. The East reactor is trying to do the same thing, but in a machine the size of a large room, instead of a ball of gas 1.4 million kilometers wide. Step 1, the fuel. The fuel is 2 types of hydrogen, deuterium and tritium. Together, they're called DT plasma. In the East reactor, this gas is injected into a hollow donut-shaped chamber called a torus. Step 2, the heat. Now you need to heat this gas to 100 million degrees. That's hotter than the sun's core. How do you heat something that hot? You use powerful beams of neutral particles. Think of them like microscopic bullets, fired directly into the gas. As the gas absorbs this energy, it gets so hot that the electrons are stripped away from the atoms entirely. At that point, it's no longer a gas. It's plasma, the 4th state of matter. Step 3, the magnetic cage. Here's the magic part. You can't touch plasma at 100 million degrees with anything physical. It would vaporize any material on Earth. So the East reactor uses massive superconducting magnets, cooled to near absolute zero, negative 269 degrees Celsius, to create an invisible magnetic field that acts like a force field, keeping the plasma suspended in the center of the donut, never touching the walls. Imagine a tornado of fire spinning inside an invisible bottle. That's essentially what's happening. The record that changed everything. Now, here's why 1,066 seconds matters. Scientists have long said that for fusion to be commercially viable, to actually generate more power than it uses, a reactor needs to hold plasma stably for thousands of seconds at a time. Think of it like a car engine. You need the engine running continuously, not just for brief bursts. Before 2025, the world record was 403 seconds, set by the same reactor in 2023. On January 20th, 2025, the East team didn't just beat that record, they shattered it, more than doubling it to 1,066 seconds by upgrading their experimental systems to double the power output while keeping the plasma from collapsing. To understand the difficulty here, imagine spinning a ball on a string above your head. Now imagine the string is invisible, made of magnetic fields, and the ball is plasma, hotter than the sun. And you need to keep it spinning perfectly for 17 minutes without it ever touching anything. That's what they did. The next layer, what East is really building toward. But here's what most coverage missed. The East reactor isn't the end goal, it's the training ground. Every experiment East runs feeds data directly into ITER, the $25 billion international fusion reactor currently being assembled in southern France, involving 35 countries, including the US and China. East is essentially a real-world simulator for ITER.
And ITER itself is just a stepping stone to the China Fusion Engineering Test Reactor, known as CFETR, which China plans to start building around 2030, capable of producing between 200 and 1,000 megawatts of fusion power. That's enough to power hundreds of thousands of homes. Then, between 2040 and 2050, a full commercial fusion power plant. China isn't just doing science experiments. They have a 25-year industrial roadmap, and they're executing it, step by step. The magnet breakthrough nobody talked about. And in March 2025, just 2 months after the East record, a Shanghai-based startup called Energy Singularity announced their new high-temperature superconducting magnet had generated a magnetic field of 21.7 teslas,
breaking a previous record held by the United States. Why does this matter? Because stronger magnets mean smaller, cheaper reactors. It's the key to making fusion commercially viable. China didn't just break one record in 2025. They broke two.
Let's zoom out. Because what's happening in a lab in Hefei, China, isn't just a science story. It's a power story. The $2.1 billion signal. In July 2025, China did something remarkable. It launched China Fusion Energy Co. Limited, CFEC, a state-owned company whose sole purpose is to commercialize nuclear fusion company. At its founding, CFEC had registered capital of $2.1 billion. That made it, at launch, the single largest fusion energy company in the world by capital. Here's the number that should make Washington uncomfortable. That $2.1 billion, the starting capital of a single Chinese state company, is 2.5 times the entire annual US Department of Energy fusion budget. China is spending roughly $1.5 billion per year on fusion. The US, about $800 million. And while China has 5 major facilities operating or under construction, the US has 0 fusion demonstration reactors in the pipeline. Why the AI race makes this even more critical. Here's the connection that almost nobody is making. The AI boom is creating an energy crisis. Global data center electricity demand is expected to more than double by 2030. The AI models powering ChatGPT, Gemini, and every other system require enormous amounts of electricity. Cheap, continuous, reliable electricity. China's own AI build-out, including the massive DeepSeek data center in Ulaanbaatar, is already straining the power grid. That's exactly why Beijing committed $2.1 billion to fusion in the same year that DeepSeek shocked Silicon Valley. Whoever powers AI wins the AI race, and whoever cracks fusion powers everything. What this means for US energy dominance. For the past century, the United States built global influence partly through energy dominance. The petrodollar system, military presence in the Middle East, sanctions leverage, all of it was backed by energy power. If China becomes the first nation to achieve commercial fusion energy, to generate electricity from fusion at scale, the geopolitical implications are massive. China would have energy independence from fossil fuels, eliminating a key vulnerability. China could offer fusion technology and reactors to developing nations, building economic alliances that bypass Western financial systems. Chinese AI infrastructure would have access to near unlimited, ultra-cheap electricity, a decisive advantage in the AI race. The United States, still debating oil pipelines and coal plants, could find itself structurally behind in the energy technology of the 21st century.
This is the pattern we've seen before. China identified battery technology as strategic. Now they dominate 80% of global EV battery production. China identified high-speed rail as strategic. Now they have more HSR track than the rest of the world combined. China identified solar panels as strategic. Now they manufacture over 80% of the world's solar panels. Nuclear fusion is next on that list. Is China already winning? To be fair, fusion is still not a solved problem. The East reactor, for all its records, still uses far more energy than it produces. The road from 1,066 seconds to a working commercial plant is long and uncertain. China's own state nuclear company acknowledged that fusion still faces uncertainties and even risks of commercial failure. But here's the critical difference. In the United States, fusion is largely private sector. Companies like Commonwealth Fusion Systems and TAE Technologies are doing impressive work, but they're dependent on investors, market conditions, and quarterly returns. In China, it's a national priority, backed by the full financial and industrial power of the state, with a 25-year plan and no election cycles to interrupt it. The race isn't over, but one side has shown up, and the other is still debating whether to fund the bus ticket.
So let's bring this home. On January 20th, 2025,
A machine in Hefei, China held a star-hot plasma stable for 17 minutes and 46 seconds. A world record. A milestone that scientists said for decades was impossible. 6 months later, China launched a $2.1 billion state-owned fusion company, the biggest in the world, with a single mandate: turn this technology into commercial reality. And while the US spends less than half of what China spends annually on fusion, and while Washington debates energy policy in election cycles, China is executing a 25-year industrial plan that ends with a working fusion power plant. If they pull it off, the country that cracks fusion first doesn't just win a science prize. They win energy independence. They win the AI arms race. They gain unmatched geopolitical leverage over every nation that still depends on oil, gas, and coal. And history will record that while the world was distracted, someone quietly built an artificial sun and changed everything. This is what World Shift is about. Not headlines, not hot takes. The real forces reshaping the world, explained simply, backed by facts. If this video gave you a new way to see what's happening out there, hit that subscribe button and turn on notifications. Because every week we're going to bring you the stories that matter. The technology, the power shifts, the mega projects, the things that are actually building the world of tomorrow. Understanding what's coming starts today. We'll see you in the next one.